In this video, I'm going to show you how to solve for simultaneous equations at a grade 11 level. Simultaneous equations are basically when you have to solve for two or more unknown variables at the same time. But in grade 11, it will only be two variables usually. So in order to do this, you have to put one of the variables in terms of the other variable, making several equations and eventually substituting back to find the second missing variable. So that might sound a bit confusing, so it's best to go through an example. So we're first going to do examples that use linear equations, and then we'll move on to more challenging ones where the equations the one is quadratic and the other is linear. So the first step is to first look at your two equations and decide which one you're going to first make subject of the formula. My recommendation is to find one of the formulas that has the variable by itself and make that variable the subject of the formula. So in this case you have 2x plus y equals 5 and x minus 3y equals 13. So you could reasonably make y equals, or in the second equation make x equals, to make just a single variable the subject of the formula, which is your goal. So I'm going to leave the first formula as is, 2x plus y equals 5. And for the second equation, I'm going to make x the subject of the formula. So x equals 3y plus 13. So all I've done is I've isolated the x by taking the negative 3y over to the other side. What you do next is you label your two equations. I'm going to label the one that I've made the subject of a single variable 1, and the other one is going to be 2. Then you write out an instruction. Sub in 1 into 2. So this is telling your marker that you're now substituting equation 1 into equation 2. So this means in equation 2, whenever we see an x, we're going to substitute in 3y plus 13. So 3y plus 13 will go in x's place. So 2 open bracket 3y plus 13 plus y equals 5. And now we solve. So 6y plus 26 plus y minus 5 equals 0. 7y plus 21 equals 0. 7y equals negative 21. Divide by 7 on both sides. Therefore, y is equal to negative 3. Now that is going to be equation 3. And then what we write, we want to get the x value. So we can say sub in 3 into 1. So what I'm doing now is I'm substituting in negative 3 for y into equation 1 to get the x value. So therefore x equals 3 times negative 3, the y value, plus 13. So x equals negative 9 plus 13, which equals 4. So now we have our two answers. What this means mathematically, we've got two straight line graph formulas. When we make them equal like this, we're finding the 2 points, or the point rather, where these two graphs intersect. So we can write our final answer as a coordinate. So 4, negative 3, the x value, and then the y value. And that's your final answer. Okay, question B. Same question, solve for x and y simultaneously. 6x minus 3y equals 1 and 4x plus 6y equals 6. So our first step again is to get a variable by itself, either x by itself or y by itself, and make that the first formula. So let's do it for this first equation. 6x minus 3y equals 1. Let's factorize that left-hand side. Take out a common 3 and we're left with 2x minus y equals 1. Let's divide both sides by 3 so we can get the bracket by itself. Those 3's cancel. So 2x minus y equals 1 over 3. Let's make y the subject of this formula. So let's keep the 2x on this side and bring over the negative third. It becomes negative a third, and take the y over so it's positive. Because what you want is a positive variable by itself. So that becomes equation 1. And equation 2 then will be the other equation. 4x plus 6y equals 6. So we could have done something to this equation to make x or y the subject of the formula. So it doesn't matter which you do, but the goal is perhaps to do the simplest one so the maths is a bit easier for yourself. But you will get to the same answer ultimately, regardless of which one you choose. So this is number 2. So then we tell our marker what we're doing. Sub in 1 into 2. So it's important to lay it out nicely like this and tell your marker what you're doing. So this means wherever we see a y in the second equation, we're going to put in 2x minus a third. So 4x plus 6 times 2x minus a third equals 6. Now let's solve for x. 4x plus 12x minus 2 equals 6. 16x equals, take that negative 2 over, 8. Divide by 16. The 16's cancel, so x is equal to 1 over 2. And that becomes our third equation. So now we tell our marker what we're doing. Sub 3 into 1. So we're now substituting x equals a half into our first equation, which is 2x minus a third equals y. So we can get the y value. So 2 times a half minus a third equals y. So we're left with those 2's cancel, so it's 1 minus a third equals y. So therefore y is equal to 2 over 3. So the coordinate value of where these two graphs intersect is a half and 2 over 3. The x and the y coordinate. X, y. You don't have to put in x and y, I'm just doing that to show you. Okay, so those are when the two equations are linear. Let's move on to examples where the one is linear and the one is quadratic. Okay, so solve for x and y in the following equations. So again, we make whichever one feels the easiest the subject of a single variable in a formula, and then we make that equation the first and we substitute that into the second equation. So let's make x the subject of the formula here. So x minus y equals 5. So x is equal to y plus 5. And let's call that our number 1. And then we can call x squared plus y squared equals 13, our second equation. Then tell your marker sub 1 into 2. So whenever we see an x over there, we substitute in y plus 5. So that means y plus 5 squared plus y squared equals 13. And let's solve for y. So y squared plus 10y plus 25 plus y squared equals 13. 2y squared plus 10y plus 25 minus 13 equals 0. Because of the square, it's a quadratic. So we're going to have two answers here. So 2y squared plus 10y plus 12 equals 0. We can take out a 2. So y squared plus 5y plus 6 equals 0. And we divide by both sides by 2 to get rid of that 2. So we're left with y squared plus 5y plus 6 equals 0. And if you factorize that, you will get two brackets with factors of 6 of 3 and 2, and they're both positive. So y equals negative 3 or y equals negative 2. And then we can call these two our third equation. And we substitute again, sub in 3 into 1. But now we're going to have two parts, right? So let's make a line. So our equation 1 is x equals y plus 5. So x equals y plus 5. So now we substitute in firstly negative 3. So x equals negative 3 plus 5. Therefore, x equals 2. And let's do the other side. X equals y plus 5. X equals negative 2 this time plus 5. So x is equal to 3. So our two coordinate sets are 2, negative 3 and 3, negative 2. So these are the two places where these two graphs intersect each other. They intersect at 2 points. Okay, I hope that helped to understand simultaneous equations. So just remember the key steps: to first put one variable by itself equaling the rest of that equation. Then you make that the first equation and the other equation the second. You tell your marker substitute 1 into 2. Then you actually do that. You get your value. Then you substitute it back into the first one. For